Well, in this video, I'm going to present my web graph solver project. So here is my personal website. It updates all the progress I've ever made in this project. And here is my report, explanation of the techniques I've ever used. And you can see here's a link. This is a link to my web application. You can click on it and it will show up. This is how my project looks like. I know it doesn't look good right now, but you will find out. Right now you choose a file, it will shows up, choose a CSV file, and you will see it becomes a graph with nodes and links, and the numbers of the nodes, it will all shows up. And you can do some operations with this graph. It's interactive. You choose find simple paths between 2 to 3, node 2 and node 3. Click on it and it will be colored with red. Yes, and you can drag to see the more of the structure of this graph you've made. And you can also judge whether a path is a simple path. You can use any delimiters here. Let's find a path like 1, 0, 3, 1, 0, 3. Is it a simple path? Yes, it is. What if it's 1, 3, 0? Is it a simple path? No, it isn't. And if you click on the constraints, it will calculate all the constraints for you here, every node. And you click on the effective size, it will show up all the effective size of this graph. And also the local constraint, if you want to calculate the local constraints, you can name 2 nodes. Like for 0 and 3, it's local constraint of V, which means 3, node 3 between node F is 0.11. Also, you can choose the times you want to swap about this graph and swap it. Let me choose like 10 times swap, and you will see, look, the graph becomes totally different because it does the swap operations. You can even have more swaps here. And every time you click on this, it will just random swap this graph and it returns a whole new graph. And also, here you can load the graph CSV as a directed graph. You can see here are the arrows that shows the direction it goes, and this makes you return a tournament graph with n nodes. Let's say 10 node tournament graph. You see, it's very complicated graph here. But you can still drag it to see more of this graph. And also, if you click on the Hamilton path, you can find out the Hamilton path of this graph. It's really easy and easy for the user to use, easy for the user to see. You can also find if the 0 to 1 is reachable. Is it? It is. Yes. You can drag and see 0, 1. It is reachable. It's marked red. Is this graph strongly connected? Yes. It qualifies all the definition of strongly connected. Is it a tournament graph? Yes, it is. Let's test it with another graph here. This test graph. Is it a tournament graph? No, it isn't. Is it strongly connected? No, it isn't. And also you can calculate the reachable functions here. Whether 5 to 0 is reachable, I think it's not. 0 to 5 is reachable. Yes, yes, it is. And also we can calculate score sequence here. Because once you click on it, the score sequence will shows up. Let's generate another random tournament graph. Score sequence clicks on it, and each node will be named with its score sequence. So here's my presentation, and this is my project. It's a very interesting program with very live techniques and fun to interact with. Thank you for watching this.